Okay, so now we're going to take some notes so that we can put them into our journal so that you have a great resource to use to study from for your test that's coming up soon. So these notes are specifically on fossil fuels. So if you will remember, fossil fuels are a non-renewable natural resource. Non-renewable, the word itself actually means not able to be made new again. And when we say that and we're talking about natural resources that are non-renewable, we're talking about resources that cannot be made new again in a human's lifetime. So in an average human lifetime, we cannot recreate these resources. Now we're specifically talking about fossil fuels, but let's remember, there's other resources that are non-renewable. Almost anything that you dig out of the ground except for water. So minerals and gemstones, those kinds of things are also considered non-renewable. They take millions of years to form. Millions. That's why they are non-renewable. We don't live millions of years, so we won't be able to see these resources form in our lifetime. Once they're gone, they are gone. If we use them all up, they will not be remade in our lifetime. So because of this, we need to be careful and not be wasteful of our fossil fuels. Our three fossil fuels that you need to know are coal, oil, and natural gas. One good way to help you remember coal, oil, and natural gas is that it's each state of matter. Coal is a solid, oil is a liquid, and natural gas is a gas. Now, all three of these are formed in layers of sedimentary rock. From plants and animals. Plants and animals are also called organic matter. I know you've heard that word before. So sedimentary rock, let's review. We've already learned how sedimentary rock is formed. Rock is weathered down into little tiny pieces, which we call sediment. Those sediments are eroded, which are carried away, and then deposited or left behind in a new place. And these layers stack up on top of each other, and pressure and heat cause cementation and the compaction of these rock layers to make them stick together and harden and form sedimentary rock. Now, when ancient plants and animals get trapped inside of the sedimentary rock, if the conditions are perfect, then those plants and animals can turn into fossil fuels. We use fossil fuels for energy. So we use fossil fuels for energy in our homes and in our schools and in our businesses, and fossil fuels are really important to all of us. If we waste our fossil fuels and we run out of them, our life would change dramatically. Most of the electricity that we use in America comes from coal, and coal is non-renewable. Now here's a quick memory device. Just like we use NCIS to help us remember what is magnetic, we're going to use FF equals con to help us remember what is a fossil fuel. So if you've already figured this out, that's great. That means it'll stick in your brain even better. So the FF stands for fossil fuels. And what does the con stand for? I'm sure you know. So fossil fuels equal coal, oil, and natural gas. So this is your strategy. Whenever you have questions that ask you about fossil fuels, you're going to write FF equals con, and you're going to know that fossil fuels equals coal, oil, and natural gas. Now down below here we have an area where we're going to fill out a flow map of how oil and natural gas and coal are formed. They're very similar in formation. I'm going to be using colors while I'm taking these notes, so if you want to color yours too, you probably should, because it'll make it a little bit easier for you to study. So oil and natural gas are formed almost exactly the same way. The only difference is heat. Add a little bit more heat and your oil changes into a gas. Now we know this because we know that states of matter can change by either adding heat or taking heat away. It's basically the same concept. So let's start at the beginning. To form oil and natural gas, we have to start out in the water. So oil and natural gas form in the water from tiny little ancient plant and animal organisms. Of course, I'm going to break my pencil. So these little dots are going to represent the microscopic plant and animal organisms that are floating around in my ocean water. So here's our water, and ancient plant and animals die. In the water, and when they die, they sink down to the bottom. I gotta have my water be a little bit blue. They sink down to the bottom. So here's our water, and our ancient plant and animal matter, our organic matter, has now sunk down to the bottom of the ocean floor, where it lays down here, beginning to decompose. And during this decomposition, something amazing happens. It gets covered by sediment. So these organisms sink to the bottom. Should have made my boxes bigger. Once they sink to the bottom, they're going to get covered by sediments. So I'm going to draw in some layers. They get covered by sediments. There we go. Here's our sediments layering up on top of this ancient plant and animal matter. I didn't color my water over here and here. So once it is covered by the sediment, then this is the key. We have to have millions of years of pressure and heat. So this is pressure and heat for millions of years. So we're going to have our layers. I'm going to draw this little fiery looking thing here to represent the heat. And where is that heat coming from? It's coming from the inside of the earth. Remember, the inside of the earth is really warm. So the pressure is coming from the sediments pushing down on the rock layers, and also from gravity pulling down. And the heat is coming from the inside of the earth. And all of that, if it's just right, will then change those ancient organisms into oil. So inside of this rock layer, we will end up with oil formation, which oil is a liquid. It's black. The big kid word for oil, do you know it? I hope you do. It's called petroleum. So here's our layers. We had all that pressure and heat, and we ended up with oil. Now, most of you already know that you have to dig down into the ground to get the oil out. So there's our oil. Now, how do we get our oil to change into gas? Well, it's pretty simple. We have more heat. And if we have more heat, then liquids change forms. And so our oil deposit is still there, but some of that oil has turned into a gas, and it's there, and then that is oil. And all of this is still in the layers of the sedimentary rock. And we still have that heat going on. And that is how oil and natural gas are formed. So this happens in the water. Now, that's what's different between oil and natural gas formation and coal formation. So coal formation happens a little bit differently. Coal is not formed in ocean water or in large bodies of water. Coal is formed near swampy areas, and it's usually formed from plant matter. So we've talked about fern plants, right? So we talk about ferns because ferns are typically in these areas where coal is formed, but basically any type of plant matter that can die near a swampy, marshy area and fall into this swampy ground. So it starts out with the plants getting energy from the sun. And when they die, these plants then fall down and get trapped inside of our swampy area. So they die and fall into the swamp. And then the same step happens as far as the sediments. Are you noticing a pattern here? You can't have fossil fuels without sedimentary rock. So this lovely little plant that has died, or lots of plants, these ancient plants from millions of years ago, they get covered up with layers of sediment. Can you guess the next step? So the next step is millions of years and what happens is we have those layers pressing down, and that plant matter gets changed into something that is called peat. Not peat like the name Pete, but peat, P-E-A-T, P-E-A-T. Okay, you're going to notice that I skipped ahead a little bit. I ran out of time. So that peat, with pressure and heat and more time, will eventually change into what we know as coal. So this more pressure pushing down and more heat from within the earth will change that early form of coal, or peat, into what we now know as coal. Excellent. So now you're going to take this and you're going to put it in the journal. I'll show you an example of where it should go.